Alright, so this is our power source, a 9-volt battery connected to our DP-DT switch. You can go two different directions. And that goes to our potentiometer, to our brackets, copper coil, magnet right there, then back to the DP-DT switch.
Now we're going to go forward at 2 speeds for 25 seconds total. Alright, now we're going to go in the reverse direction at 2 varying speeds for 25 seconds. Okay, so right here we have a coil, and we have 2 charged brackets that are creating a magnetic field. And when we add the magnet right here, we allow the coil to turn, and it's either turning from the greatest point of attraction, which would be in our forward direction, or it's going in the greatest point of repulsion, which would be in our backwards direction. And this all depends on how the poles of the magnet and the brackets are aligned.
I don't think that's right.
That is right.
The movement of the coil turning to the point of greatest attraction or repulsion is an example of electrical energy being converted into mechanical energy. The only problem is that the coil moves a little way and then stops because it reached a point of greatest attraction or repulsion.
You want to keep the coil spinning, so the only way to do this is to reverse the current in the coil. If you reverse the poles of the field that it's generating, the field and the magnet now have a movement of equilibrium, and the coil continuously moves to that.
As the coil reaches the next point of equilibrium, where it should stop, the equilibrium point is moved over to the next point around the circle to keep the motor turning, and this is repeated over and over again, so the coil continuously turns. The motor is kept turning as long as electricity is being fed to the coil. This means that the electricity being fed to the coil is being converted into mechanical work, which is the motor turning.